So far with dividing radicals, we've handled basically one term being divided by a second term. So just to recap real quick, if I had something like the square root of 15 over the square root of 10, first of all, because those have a common factor and they're both under the root, I can reduce them with each other. So if I reduce 15 and 10, that gives me 3 over 2. So I have the square root of 3 over the square root of 2. I'm still not allowed to leave a square root in the denominator, so to fix it, I can multiply by the square root of 2 over square root of 2. And up top, I get square root of 6, and on the bottom, I get square root of 4, which is just 2, right? So that's what we had learned last time. The same rules kind of apply. I'm basically just trying to get rid of a square root in the denominator, but some weird things might happen. So let's try, before we make things too complicated, let's say I had x minus root 6, and I wanted to divide that by, I don't know, root 3. So I still can't have the square root in the denominator, but here's the difference now. This is now not one term. There's two chunks to this. This is a binomial, right? So I'm not allowed to reduce those two, even though they're both under the root. He's tied together with the x with a plus or a minus. So if you remember from the last chapter, if something's in a binomial, you can't reduce part of it. You'd have to have the exact same binomial on the denominator in order to cross the whole thing out. So that's a big mistake if you cancel the 3 and the 6. You can't do it here. But I still can't leave a square in the denominator. My fix is the same as it was before. I'll just multiply by the square root of 3 over the square root of 3. Just be careful now, in your numerator over here, you're going to have to distribute because you have two pieces. So we're going to multiply that square root of 3 to both of those parts. Okay? So this becomes square root of, actually, we should put the x first and then the square root of 3. So x square root of 3 minus square root of 18. And that would be all over 3. I do have to fix the square root of 18 because it does have a perfect square that goes into it, right? So wouldn't square root of 18 become, it would split into 9 and 2, so that's 3 root 2. And there's my final answer. So if I have a binomial on top, I just have to make sure that I distribute to both. Let's try another one. This is number 11 from your the back of the homework. 3 minus 3 times the square root of 3a all over 4 times the square root of 8a. All right, so the numerator is a binomial, so you cannot reduce just these radicals with each other. I wish I could, but I can't.
Please pardon the interruption. At this time, those students eating second lunch, please report to the cafeteria.
All right, so I do have one other option. I can simplify the square root of 8. I can either do it now or I can do it at the end. I'd probably do it now, just because if I don't, I'm probably going to have more that I have to fix later. So let's fix our denominator. So the square root of 8, isn't that the square root of 4 times the square root of 2? So that'd be 4 times 2 times square root of 2, or 8 root 2. And then I do still have that a underneath there. So that's really my new denominator. So actually, let me rewrite it. 3 minus 3 root 3a all over 8 square root of 2a. Is everybody okay so far? Did I lose anybody? So now I just got to get rid of the square root in the denominator. So what would I multiply by? Square root of 2a over square root of 2a. And again, this is a binomial, so I'm going to have to distribute to both. So go ahead and write what you think you get as a new numerator when you distribute the square root of 2a to both of those. When you're done, you can look up at the screen and see if we got the same thing. Oh, yeah. Bye. Good luck.
Where's she going?
You really want to know?
Sure.
She has to go to the hospital and get a heart monitor put on.
Does she have heart problems?
She keeps getting dizzy. So they're trying to figure out why.
Oh.
Okay, so if I distribute the square root of 2a to both of these, I get this. Is that what you got? And then I just have to do the same thing on the denominator. Square root of 2a times square root of 2a is just going to be 2a, right? When you square a square root, it just undoes it. So now I have 2a times 8, or 16a. Am I done? That's my question to you now. So you're done if there's no like radicals that you can combine, you don't have a square root in the denominator, and every radical that you do have is fully simplified. So I don't have a square root in the denominator, that's good. I don't have like radicals, so I can't combine those two. Are all of my radicals fully simplified? In other words, 2 doesn't have a perfect square factor, so I can't do anything there. 6 doesn't have a perfect square factor, so I can't do anything there. However, can I take the square root of a squared? Yeah. So that's the only little thing that I have to do. What is the square root of a squared? Just a. So my true final answer is 3 square root of 2a, and then over here that a is just going to pop out, so I'll get 3a square root of 6 all over 16a. And that is a totally complete final answer. Okay, are you ready for things to get real weird? Good. Okay, let's try it. How do you think you handle something like this? Let's keep our numbers nice. Say you had like 5 over 3 minus the square root of 2. So now I do have a binomial, but it's in my denominator. So remember the rule. I'm not allowed to have a square root in the denominator, so I need to get rid of it. There's nothing I can simplify here to start off with. So how am I going to get rid of that square root of 2 in the denominator? So that's a really good guess. Well, let me back up. Usually, the most common guess is to just do the same thing I have been doing and multiply by the square root of 2 over the square root of 2. Don't you write this down, but watch what happens if I try that in a case like this. Up top, I get 5 root 2, and then on the bottom, I have to distribute, so that would get me 3 root 2 minus 2. Did you get rid of the square root in the denominator? No, you just moved it from this side to this side. It's still there. If you tried to multiply again by a square root of 2, you're not going to get anywhere. You're just going to keep, it's not going to ever get rid of the square root in the denominator. So, Jordan's idea was very interesting. He did not say just multiply by square root of 2. He said multiply by the whole denominator. Whoa. So he said multiply by 3 minus square root of 2 over 3 minus square root of 2. So Watch what happens in this case. Don't write this down either. Because unfortunately he's not right, but he's close. So that would get me 15 minus 5 root 2. And then in the denominator, you have a binomial times a binomial. You have to FOIL those together. So first I get 9. Outsides I get minus 3 root 2. On the insides I get minus 3 root 2. And then the last negative root 2 times negative root 2 is now positive 2. So I'd actually get 11 minus 6 root 2. Darn, I still have a square root in the denominator. And you might be thinking, oh, just cancel those two out. You can't, because it's a binomial and a binomial. They have to, the whole thing has to be identical. You can't cancel parts out. But I said he was close. Anybody have any guesses what I do? Alexandra?
Multiply by its opposite.
What do you mean?
Like, instead of multiplying by positive.
Yes. So there's a fancy, if you look back at this is on the multiplying page. Remember we did this one problem in class up on the board? You multiplied those two together and it just came out to be 2. Do you remember that the other day? You're like, wow, look, it was so nice. Look at those two binomials. They are exactly the same, except one's a plus and one's a minus. When that happens, these are called conjugates of each other. So it's the exact same binomial, but in the middle, you just have opposite signs. So if I go back to this, if I had multiplied by 3 plus root 2 on top and bottom, watch what would have happened instead. So first of all, that would get me 15 and then plus a 5 root 2 on top. But then on the bottom, watch this. First, still 9. The outsides would now be a positive 3 root 2. The insides are a negative 3 root 2, and then negative root 2 times a positive root 2 would have been a negative 2. But then when I combine like terms, those two cancel each other out. And they always will if you multiply by the conjugate. So, positive 3 root 2, negative 3 root 2, they're gone. And now I just have 9 minus 2, 7 is my new denominator that doesn't have a square root in it. So, that's what we need to do. So, if you need to write that down in words, a big old star, if your denominator is a binomial, you must multiply by the conjugate. So that's how you spell that word, conjugate. And conjugate is the same binomial, but change the middle sign. So let's do 16 together. 16 is 5 over negative 5 minus 3 root 3. Okay, so what am I going to multiply by to undo this? You're almost right. It's only the middle sign that you change. So that negative 5 is still going to stay a negative 5. If it was a positive 5, it's going to stay whatever it is. It's only the one in the middle that gets changed. So I want to do negative 5 plus 3 root 3. Negative 5 plus 3 root 3. Oops. Okay, so Make sure up top you have to distribute, so that should be a negative 25 plus 15 root 3. And then down on the bottom, I just have to FOIL those two together. And this is another reason why I like math so much, because it self-checks itself. If my radicals don't cancel out, something's wrong. I've made a mistake somewhere, right? So let's FOIL it, just like I normally would, and we'll see if those radicals really do cancel out. And if they don't, I know I need to go back and fix something. So first, negative 5 times negative 5 is positive 25. Outsides. What would you get when you multiply the outsides together? Negative 5 times 3 root 3. Wouldn't it be negative 15 root 3? Right? Insides. Now I'm going to get a positive 15 root 3. And now be careful when you do the last. Go ahead and figure out what you think you get when you multiply negative 3 root 3 times positive 3 root 3. Well, you know the sign's got to be what? Sign's got to be a negative, because I have a negative times a positive. So what's 3 root 3 times 3 root 3?
It's just 3, because it's the square root of that.
Well, 3 root 3 times 3 root 3. Let me write it out. 3 root 3 times 3 root 3. 3 times 3 gets me 9. And then root 3 times root 3 gets me 3. So 9 times 3, 27. So, yes, these two cancel each other out just like they're supposed to. So now I just have 25 minus 27, so I get negative 2. And that is my final answer. Is that all right? Is everybody okay? By the way, I just want to show you a type of answer that can be simplified. This one can't. But let's just say you had an answer that was something like this. I don't know. How about 8 root 3 minus 6 root 2 all over 10? That can be reduced. And here's why. Because all three of these, the 8, the 6, and the 10, all three of them are not in the house, and all three of them have a common factor. So I can reduce them all with each other. So I would divide everybody by 2, right? So it'd get me 4 root 3 minus 3 root 2 all over 5. What you can't do is if you had an answer that was this. Say you had 8 root 3 minus 5 root 2 all over 10. All three of these don't have a common factor. You can't just do the 8 and the 10 with each other, or the 5 and the 10 with each other. It's got to be all of them together or none of them. Okay, so this one I can't factor at all, but since these, all three of them, that was fine. Does that make sense? So the answer that I just got on this one, all three of them, the negative 25, the 15, and the 2, collectively don't have a common factor. So I'm done. Should we do one super hard one and then kind of be done? 25, did we say? 25? Okay.
One.
In 20 minutes. Okay. I'm going to do the very last, oh, that one's really bad. So let's do it together. 22. The very last one on the homework sheet. So that one is 3 minus 4 root 3 over 4 root 5 plus 3 root 2. All right, so I need to get rid of 2 square roots in the denominator, but it's okay. I get rid of them both at the same time, as long as I multiply by what? So the sign, only the sign in the middle changes. No matter what, only the sign in the middle. So I want 4 root 5 minus 3 root 2, top and bottom. The reason why this one is particularly difficult is I'm going to have to FOIL twice. I have to FOIL in the numerator and in the denominator. Oh well, that's the way the cookie crumbles sometimes. So up top, let's see if I FOIL those together. I didn't leave myself much room, but that's okay. First, I'm going to get 12 root 5 outsides. Minus 9 root 2, right? 3 times negative 3 root 2, minus 9 root 2. Insides, what would that get me? Negative 4 root 3 times 4 root 5 would get me what?
16.
Perfect. Negative 16 root 15. And then the last, positive 12 root 6. So before I go ahead and do my denominators, I'm just scanning here and I don't see any common, I don't have any common radicals. I also don't have any radicals that need to be simplified, so that's convenient. Otherwise I'd have to do it, but they all look fine. I just so happens to be 4 totally different radicals. Now when I go ahead and do the denominator, believe it or not, all of my square roots should cancel out. Let's see if they actually do. So first, what do you get when you multiply 4 root 5 times 4 root 5? Well, 4 times 4 is 16, and then root 5 times root 5 would just be 5. So 16 times 5 is 80? Is that right?
Yes.
Okay, so there's the first, if you want to keep track, because there's a lot going on with this one. 80, okay, and then outsides. So that's going to get me a negative 12 root 10, right? 4 times negative 3 is negative 12. Root 5 times root 2 is root 10. All right, that's not so bad. What do you get when you do the insides? 3 root 2 times 4 root 5 would be positive 12 root 10. Oh, cool. All right. And then the last, I have a positive times a negative, so I know it'll be negative. 3 times 3 is 9. Root 2 times root 2 is just 2. So 9 times 2, 18, right? No way! So the two middle terms cancel each other out because it's a negative 12 root 10 and a positive 12 root 10. So I just have 80 minus 18, which is 62. So, although this one looks terrible, it wasn't that bad. You just go piece by piece by piece by piece. Can you simplify this answer? Again, you'd have to check that all of these numbers, in this case you have 5 of them, 12, 9, 16, 12, and 62. If they all have a common factor, you can reduce by it. But I don't think they do. Right? I can't divide them all by 2. I can't divide them all by 3. Can't divide them all by 9. Yeah, I think that's it. What do you think? Are we all right? Everybody's okay? All right, so let's stop this then.